So hello everyone, our today's topic is ESR. So what do you mean by ESR? Remember ESR, it is measure of rate at which R, B, C they settle in a particular column of the blood over specific period of time. So what is ESR? ESR is basically how fast the red blood cells settle down in a test tube. So normally these cells they float around in your blood and don't sink. But if there is inflammation or infection, they can stick together and sink faster. So imagine we take a small amount of your blood and mix it with a liquid that prevents it from clotting, that is anticoagulant. Then we let it sink in a tall thin tube. Over time, if there is inflammation, the red blood cells they start to settle down to the bottom of the tube because they become heavier. And the clear fluid that is present on the top, that is plasma. So doctor, but they use ESR as clue to figure out what might be going out in your body. So remember, high ESR means there is inflammation like from the arthritis, infection, and lower ESR is usually normal but can be a sign that everything is okay. So why is ESR important? It is a simple test that gives doctor clue about the diseases like infection, inflammation. It does not pinpoint exactly where the problem is, but it helps to confirm if something might be wrong. Now, in order to calculate the ESR, we use the two methods. The first is the Westergren method. So remember the most widely used technique for ESR determination is the Westergren method. So first of all, blood is drawn into a Westergren tube. So this one is the Westergren tube, that is long, narrow tube. And the calibration here is in mm with internal diameter of around 2.5 mm. So here the blood is mixed with an anticoagulant. Anticoagulant we use is sodium citrate in a ratio of 4:1 ratio in order to prevent the clotting. So the well mixed blood is introduced into Westergren tube until it reaches the 200 mark. The tube is then placed vertically in a rack and it is left undisturbed for 1 hour at a room temperature. So after 1 hour, the distance that the red blood cells have settled is measured from the top of the tube to the upper limit of the red cell column. Other method we use is the Weintraub method. So Weintraub method, remember, it is another technique that is used to measure the ESR. Here the blood is collected into Weintraub tube. The Weintraub tube is similar to the Westergren tube, but it has a smaller bore diameter of around 1.5 mm. Here, like the Westergren method, here the blood is also mixed with anticoagulant. The blood anticoagulant mixture is added to the Weintraub tube, filling it to the mark level 0. So the filled tube it is placed in centrifuge and it is spin at high temperature for 1 hour. So after centrifugation, the height of red blood cells column and the total height of the blood column are measured. So the ESR, it is calculated as the ratio of the height of red cell column to the total height of the blood column, that is expressed in the percentage. So remember, basically Western gun method, it measures the distance of sedimentation in mm/r ratio, whereas the Winthrop method, it measures the ratio of sedimented red cells to the total column height, and it is measured in the percentage. Now let us discuss the factors that can affect the ESR. The first is increase in the RBC. Larger RBC, they settle faster, that increases the ESR. Other is a specific gravity. If the red blood cells become heavier, they settle faster. That means that increases the ESR. Other is the Rolex formation, that happens when the RBC, they stick together and that make them settle faster, and hence increasing the ESR. What are the factors that can decrease the ESR? That could be blood viscosity. If the blood, it becomes thicker, that is, it becomes more viscous, so it slow down the settling of the RBC. That means it will lower the ESR. So that can happen only when there are more protein or cells in the blood. Second is when there is an increase in the number of RBC. So more red blood cells means thicker blood that resist settling faster and lowering the ESR. Now what are the variation in the ESR? Let us discuss that. First is the age. ESR is lower in the children and infants because they have more red blood cells. Women, remember, ESR can increase during the menstruation due to the blood loss. ESR increases during the pregnancy due to the dilution of the blood. Now other important thing is PCV. What is PCV? It is known as packed space volume. It is the percentage of your blood that make up of red blood cells. So when your blood, it is spun in a machine, that is centrifuge, the RBC, they will pack down at bottom of the tube, that shows how much space they take. So how is this PCV measured? First, blood is mixed with a substance, that is the anticoagulant, in order to prevent the clotting. So this tube is spun really fast in centrifuge, making the RBC settle down. So the percentage of the tube filled with RBC at the bottom is your PCV. So why does this PCV matter? So it helps to diagnose anemia and polycythemia. It helps the doctor to figure out if you have too few or too many RBCs. Checking dehydration. Also PCV can show how dehydrated you are and if treatment are working to fix it. Apart from that, if your PCV is low, doctor might decide if you need more blood. That is the blood transfusion. Remember the normal PCV. The normal PCV for the males is 40 to 45%, and for females it is 38 to 42%. So there are other blood indices, that is MCV. It tells the average size of your RBC. MCH, it measures how much hemoglobin is there in each RBC. And other is MCHC. It shows the concentration of hemoglobin in each RBC. And other is important is color index. It helps to compare the hemoglobin in your RBC to normal level. So suppose if your patient has a hemoglobin of 8 gram per deciliter and PCV is 30%, RBC count is 4 million per cubic mm. Now let us discuss how can you measure. If the first is the color index, and it is measured by hemoglobin percentage divided by the RBC percentage. So that means it is 8 gram divided by 15, that comes out into 100, that comes out to be 53.3%. And RBC percentage that can be calculated by RBC count in the subject to the RBC count in the normal person into 100. So that means 4 million divided by 5 million per cubic mm into 100 is 80%. So color index is this 53.3% divided by 80% is equal to 0.67. MCV, remember, it is measured by PCV divided by RBC count in million per cubic mm of blood. So MCV is equal to PCV in 1000 ml or in 100 ml into 10 divided by RBC count. That means 30 divided by 4 into 10. So remember, 30 is the PCV and RBC count was 4. And MCH, it is calculated by hemoglobin in gram per 1000 ml of blood divided by RBC count. So MCHC is equal to 80 by 4 is equal to 20 picogram.